This is Saxon Algebra 1/2, 2nd edition, lesson 123 on polygons and congruence. So let's start with polygons. Poly means more than one. So I've got some examples. I found this chart online. I really liked it because it has pretty much everything that your book is telling you about polygons. Here at the top you have examples of what are called regular polygons. That means all sides are equal length and all of the internal angles are equal. So like an equilateral triangle, a square, which is technically a quadrilateral because it has 4 sides, a pentagon, hexagon, heptagon, and octagon. Alright, now these are called irregular polygons because it is not regular like these. In other words, they don't have equal length sides. Maybe all the internal angles are not equal, but they still are polygons. They have several sides. Alright, and then there's something called a convex and a concave polygon. Now, we're not going to talk about complex polygons in your lesson, so let's focus on convex and concave. Concave, here's the definition. It has at least one internal angle greater than 180. But I like to say, if you think of it as concave, it has a little cave. And convex is like a convex lens, okay? All of these regular polygons are called convex. They don't have the cave. They don't have any sides that are coming in. Everything's pointing out. Alright, here are some what are called non-examples. They're examples of things that are not polygons. A circle is not a polygon because technically it doesn't have a side with lines. Any shape that includes a curve, that's not a straight line, is not a polygon. If the shape is not completely closed, then it can't be counted as a polygon. And three-dimensional objects are also not polygons. Okay, so another example of regular versus irregular polygons. This is one that we would classify as a concave, and these would all be convex. Again, here are some of the names based on how many sides they have. 10 sides, for example, is a decagon. And then here are some other examples and what their names are. This is a trapezoid, and we're going to deal more with trapezoids in another lesson, in parallelograms. Rectangle, rhombus, which to me looks like a diamond, and then a square. Okay, so now let's talk about what congruence means. Congruence is like a mirror reflection of two things. So, like here, these two things are congruent because they're exactly mirror objects of the other. They're exactly the same size. They do not have to be facing each other, however, to be congruent. This is not congruent because although they're both stars of the same shape, one is much larger than the other. So if you were to put this one up to a mirror, you would not get this. These two butterflies are congruent. Alright, so what is the definition technically of a congruent shape? When one shape is transformed into another by using one of these methods: rotation, which is a turn, reflection, which is a flip over, or translation, which is simply a slide from one place to another. Then, if you can do that, then both the shapes are congruent. After the transformation, the two shapes have to be exactly the same in terms of sizes, areas, lengths, and angles. Their position is the only thing that does not have to be the same. Here's the symbol for congruence. Okay, so angle ABC is approximately congruent with angle XYZ. Okay, I want to put these in your notes, and when I say may, I mean do. Put this in your notes. A translation is a move or a slide in any direction without rotating it. You simply slide it. Reflection just means to flip it over, like in this example. You take this, you flip it over, you have this. Rotation means exactly what it says. You rotate something around. You're going to turn it a little bit, okay? Rotate or turn. Like this P, we are rotating it here, and here it's rotated, and here it's rotated. But it's all of these are congruent because they're the same size and shape as the original. Okay, so your practice problems, let's work on those. Okay, so it says all the figures shown below are polygons, and I just took the picture from your book. Figure A is also a quadrilateral, a rectangle, a rhombus, if you turn it, and a square. So, following this example, give as many names for each of these figures as you can. So, since they just gave us A, it's a convex polygon in addition to everything they listed. It's a regular quadrilateral, a rectangle, a rhombus, and a square. Alright, B, these tick marks tell us that this is an equilateral triangle. All the sides are equal. It is also a regular polygon. And I'm not going to write all this out, but you guys can. A regular polygon. It is a convex polygon. It is an equilateral triangle. Alright, C. C we can also say is a convex polygon. It is a quadrilateral because it does have 4 sides. And it is also in the shape of what we call a trapezoid. Okay, D we could say is a regular polygon. It is a convex polygon. It is a quadrilateral. It's an irregular quadrilateral. Because it has 4 sides. It is a square. If you turn it the right direction, it's a square. It could also be looked at as a rhombus. It could also be called a parallelogram because the sides run parallel to each other. Let's see, did we leave anything out? Square, rhombus. So go ahead and write all those down. If you need to watch this part again to hear me say all the things, you can just watch this particular part. Okay, E. E is a regular polygon. It is a convex polygon. It is a rectangle. It is a parallelogram. No, I'm sorry, it's not a parallelogram. It is a quadrilateral, 4 sides. It is not a square, but a rectangle. F is a parallelogram. It is a convex polygon. It is a quadrilateral. I think that's about it for F. Now G, because we've got this little like cutaway cave here, G is going to be a concave polygon. And the only other thing we can call it is a hexagon because it does have 1, 2, 3, 4, 5, 6 sides. So that's all you can put for that. Okay, and then H. H has 1, 2, 3, 4, 5, 6. H is also a hexagon because it does have 6 sides, but it is a convex polygon. It is a regular polygon because all the angles and all the sides are equal to each other. And I think that's probably all we can say about that. Alright, the next part says the pairs of figures shown below are congruent. So we already know they're congruent. Tell which movements would be necessary to place figure A exactly on top of figure B. So let's do A together. Well, the first thing we'd have to do would be to slide it, right? And that is called translation. Okay? Then we would have to rotate it around because it's standing up like this. We would have to bring it over and then rotate it, and that's rotation. And then we would have to flip it over on top of this, so it would be also reflection. Alright, for J, we of course would have to move it over. We would have to translation. And then once we got it over here, I think all we would have to do would be flip it over. So translation and reflection. For K, the only thing we need to do is slide this one exactly on top of this one. So translation is the only thing that's needed there. Alright, for L, we've got to slide, so that's translation. When we slide it, we would also need to turn it, so that is rotation. And then we would also need, see how this side is smaller than this side? This is the smaller side and this is the smaller. When you slide it and then rotate it, the sides are not going to line up, so you're also going to have to flip it, which is reflection. So you need all three with this one. With M, you need to slide, which is translation, and then you simply need to rotate it, turn it, so that this would be on top of this. You would just have to turn it a couple times after you slide it. So translation and rotation are the only ones you would need. Alright, good job. A lot of stuff covered in this lesson, but none of it terribly difficult. So I'll see you next time for lesson 124.